polynomial in standard form and use it to identify the leading coefficient, the degree, and the number of terms. Negative 4 times x plus 9 plus 2 times x cubed.
So they want us to find the leading coefficient, the degree, and the number of terms. Now, you might not know this, but you got to pay very strict attention, Chris and Daniela. Terms are separated by plus and minus signs. Last thing they say is, and the number of terms. They want us to identify. And I'm telling you, and it's a fact, terms are separated by plus and minus signs. That's why there are three terms here. The minus 4x is a term, the simple term 9, and the term 2x to the third power. Terms are separated by plus and minus signs. In this particular case, it's just two main plus signs. So there are three terms in this problem. It says the leading coefficient. Okay, it says the degree. The degree is to the third power because this is the highest exponent. This is the exponent of 1. This is an exponent of 3. 3 is larger than 1. Therefore, this is a higher exponent. The leading coefficient. The leading coefficient in this problem should be 2. It's not written correctly. It's not written in standard form. It's not written in polynomial standard form. This should be first. It should be 2x to the third power minus 4x plus 9. That is the proper way that this should be written. You have to understand that. You have to know it. All right. Recall, then let's go here first. It says standard form of a polynomial shows any like terms combined and the term by degrees in descending numerical order. In descending numerical order. Descending means going from higher to lower. Descending numerical order. Standard form for this polynomial is, as I was saying, 2x to the third power minus x to the fourth plus 9. Terms are separated by plus and minus signs. There are three terms in this polynomial. The term 2x to the third power minus 4x plus the simple term 9. Those are the three terms. So let's go look. Degree. Degree of the 4x is 1. Degree of the 9 is 0. It's a simple term. And the degree of the 2x to the third power is 3 because they're simply referring to the exponent. The leading coefficient, see, 2. I'm sure you can. That 2 will light up. That is the leading coefficient. Degree of the polynomial to the third, x to the third, the 3. Lights up. That is the degree of the polynomial. Terms in the polynomial, there are 3. 1, 2, 3 terms. Terms are separated by plus and minus signs. Okay. Let's go to the next one. It says,
what is each polynomial in standard form, and what are the leading coefficient, the degree, and the number of terms of each? Part A. 2 times x minus 3 times x to the fourth power plus 6 minus 5 times x cubed.
Well, remember I said terms. Let's just start with terms. How many terms is there? Terms are separated by plus and minus signs. 2x is a term, that's 1. 3x to the fourth is a term, that's 2. Simple
There's
term
3.
6, that's 3. And 5x to the third power, that's 4. There are 4 terms today.
It's 4.
Yep.
Okay.
And then if you put it in the correct order, it should be minus 3x to the fourth, minus 5x to the third, plus 2x plus 6. They let me do the first one the last time with the calculator, but it wouldn't let me do the second one. So let's see what happens. So it should be minus 3 x four one. Okay, got it. Plus, plus, okay, minus, oh, so we'll go back here. So now we're going to put minus 5, sorry. Minus, numbers, 5x, variables, x, so the function, this one, to the third numbers, okay. Okay, you put it in there that time, it worked. Oops, hey look, gotta put that one in there. Oh, that's the first one. Okay, that's the second one. Okay, so we'll put quadrant plus numbers 2, variables, x, so that's 3. Oh. Okay, x, oh man. If you hit space, it adds more. I didn't want that. I just wanted 1x.
Oh, I was about to say, why is it 2 x's?
Take out, okay. Okay. Plus. Okay. 6. Okay, now let's look over our work. Minus 3x to the 4th, yes. Minus 5x to the 3rd, yes. Plus 2x, yes. Plus 6. Okay. Check.
Plus 6.
So it looks like we are correct. Okay. So minus 3x to the 4th, yes. Minus 5x to the 3rd, plus 2x plus 6. There it is. All right. So let's look at this one. Now this one has 1, 2, 3, 4, 5 terms. Okay. And we know it has to be from highest to lowest. So we'll start with 2x to the 6th power. So 2 x to the 6th power. Okay. Plus, and then 2x to the 6th power. We got a 5th power here, right? So plus x, the function, this one, to the 5th number. Okay. Minus Okay, so 4. So 3x to the 4. 3. X function number of course.
Deja aquí porque viene el señor a chequear la luz y no entra María.
Okay. 4, do we have anything to the third? Yes. So plus 4x to the third. Okay. Okay, 4x to the third. We don't have any x's to the second power, do we? But we have 1, 2, 3, 4, and then we have the minus 8. X. There it is. So let's count, make sure we got all our terms in here. 1, 2, 3, 4, 5 terms. Here in our answer, 1, 2, 3, 4, 5 terms. Okay. Notice 6, 5. What degree is it? It is to the 6th degree. 6, 5, 4, 3. There's no x to the second, but there is x to the first. The leading coefficient is 2. The leading coefficient is 2. Okay, now let's check our answer. Correct answer, 2x to the 6th power plus 5x minus 3x to the 4th plus 4x to the 3rd minus 8x. So this is the correct answer, we got it right. Okay. Are there any questions so far?
No, you can move on.
Okay. Thank you. All right, so now understand end behavior of polynomial functions.
How do the sign of the leading coefficient and degree of a polynomial affect the end behavior of the graph of a polynomial function?
Okay, so this says odd degree positive leading coefficient. So let's go over it. So the degree is an odd number. Remember, the degree is the exponent. It's a leading exponent and leading coefficient. So the leading degree is to the 3rd power in this one, and the leading degree is to the 5th power in this one. Right? Here the coefficient is 0.5. Here your coefficient is 2. And in this particular case, positive leading coefficient. Positive number, not negative 2, positive 2. Not negative 1/2, positive 1/2. Positive 1x. So positive, look at the red line. Look at what direction the red line is going. And then you have the others. Now I say, and this is a trick to the trade, I'm just teaching you a trick to the trade. If you see something like this, the first thing I think of is substitute the 0 in there. I make that a 0, and I make that x a 0, and I make that x a 0, and I have h of 0. This becomes 0, this becomes 0, this becomes